I guess it's not audible. So, yes. Okay. All right, perfect. So I think we're still waiting for more people to start, but while we wait for them, how is everybody doing? So just a quick update on the things we discussed in the previous doubt solving, the recap files, like the smaller point cloud files. I did find a couple of them. I'm just changing them. Like it's taking a little bit of time on my end to convert them into a usable point cloud file for you. All right, so just give me a little bit of more time and I'll be able to share that with you by, I think, hopefully by tomorrow. Second thing was, I think one of you had asked about how do we combine uh, different point cloud files into the same one if we have to scan them together. Sorry, if we have different scans and if you want to place them together into a single file. So I found a sample file which is in multiple parts. So I'm working on that recording as well. So that also I should be able to share it with you by tomorrow. And for MEP, so I spoke with our tech team. We, I think, are facing some issues with our recording platform. So that might take a day or two more. I'm really sorry about that. But I think by Sunday we should be able to get that sorted for you. Okay. So I think those were the priority things that were discussed in the doubt solving. But yes, other than that, so did you guys get a chance to revise your previous sessions before coming today? I had reminded you all to do that before we start with Dynamo. So are you guys prepared? Are you guys ready for Dynamo? Okay. Very low energy in the session today. That's fine. Shada was prepared. That's nice. All right. So let me just brief you guys about Dynamo. So does any one of you know what exactly is Dynamo? What does it do? Does any one of you have any idea? Yes, no. Okay. So I am going to assume that you guys have heard of Rhino and you guys have heard of Grasshopper. Yes. Have you heard of Rhino and Grasshopper? Not in terms of using it or working with it, just have you heard of these softwares? Yeah. So what Grasshopper is to Rhino is what Dynamo is to Revit. All right. So the idea behind Dynamo or the purpose behind Dynamo is to automate work for you. Okay. It's to automate work for you. It's to do repetitive tasks for you. All right. So we have worked with add-ins, right? We've worked with certain add-ins in Revit. You guys work with Dyroach, you worked with Ideate, and you try to, use those plugins in order to work on multiple things at the same time, whether it is renaming your sheets or renaming your families or organizing things in a certain way. You were able to use add-ins for that, right? And there are several add-ins that Autodesk provides. Okay. But Dynamo is a way to customize that for you. All right. So, does any one of you here know coding in any language, Python, HTML, JavaScript? Does any one of you know coding or has some experience with coding? It's fine if you don't. You don't need to know how to code for Dynamo. I'm just asking a general question. No? Okay. So, let me just, explain the theory behind this process to you before we get into the practical aspect of things. Okay, so whenever you create a software or whenever, even if let's say you're creating a website, okay, the way that the website is supposed to behave, the way that the app is supposed to behave, the software is supposed to behave is all defined in a code. Okay, and these codes are written in several different languages. All right. You guys might have heard of Python. You guys might have heard of C and C++, of Java. These are all different coding languages. All right. So Revit as a software is also developed on a code. Okay. And you might be familiar that Revit is not a software that's compatible with Mac. Okay. That's because the code that Revit was written in works only with Windows. It does not work with Mac. So if they want a version that works with Mac, they have to rewrite the entire code again. Okay. So similarly, Revit is developed on a code. Okay. And since there is a level of customization that Revit offers, there is, limitations to what Revit can do by default. It also has its own coding language. Okay. That coding language in Revit is known as design script. Okay. So there are several ways of automation in Revit. Those was add-ins. Okay, so these add-ins that are created are also created on the language of design script. Okay, Dynamo also functions on design script. And there is another feature in Revit called macros. Okay, so the way that things evolved was first you had only Revit, then macros were introduced, wherein you could write a custom code and have Revit, do certain automated tasks for you. Then Dynamo came into the picture, and with Dynamo came add-ins because people could prepare a code in Dynamo and they could publish that code as an app or as an add-in. All right, so that's the evolution of how automation in Revit came to be. Okay, and Dynamo till date it is used for automation. Okay, because not everything needs to be turned into an add-in. You don't want to bulk up your system by installing a lot of add-ins for your software. So a lot of things, minor things that you might want to do, you can do it using a Dynamo script. Okay. So the way that this particular module is divided, the way that, we'll be working between today and the next session in the doubt solving is today we'll focus on understanding the anatomy of Dynamo. What exactly does it do? How do you integrate Revit and Dynamo? Okay, we'll understand that aspect. We'll, also be getting a little bit into the theory aspect of things today. Okay. Then in the next session, we will understand how do we use Dynamo in order to automate one of the things that you've already done in Revit. So you guys have, created schedules, you guys have worked with families, you've done a lot of things in Revit by now. So we'll use Dynamo to automate one of those tasks so that you understand the difference between when you're doing it manually and when you're doing it with an automated process. Okay, so we'll be doing that. And your task would also be to design a custom script. Okay. And based on that, whatever queries, whatever doubts, whatever concerns you have, we'll take that up in the doubt solve. Okay, so that's how the session is going to be divided. And for today, you are also going to have a little bit of reading material. Okay, so sorry, you're going to have a little bit of reading material that you have to go through. Okay, it's just things that can serve as a checklist for you, a sort of, just a revision of what Dynamo does, what Dynamo can do. Okay, so without further, monologuing, let me get started. Let me share my screen. Um, okay, I hope my screen is visible. So I'm going to open up a new project. Okay, I'm going to open up another project as well. Okay, this is a blank project that I've opened. I'm also going to create another project. So firstly, Dynamo is not something that you need to install. It's something that's already available for you in the Revit version that you're using. Okay. 2020 and above, Dynamo is pre-installed with Revit. It's not something that you need to download separately. So you find Dynamo in the Manage tab. In Manage, at the very end, you will have Visual Program. Okay, so here you'll have two options, which is Dynamo and Dynamo Player. All right, so Dynamo is what we use to develop the script, and Dynamo Player is what we use to run existing scripts. Okay, so what you can do is you make your code in Dynamo. You can save your code if, let's say, I don't want somebody else to know or see what my code does. I can share the Dynamo Player file with them. And that is something that they'll only be able to run using Dynamo Player. Okay, so that way it protects the code that you have created. Okay, now the reason why this entire segment is known as visual programming is because it is a way of coding. Okay, whatever you are doing in Dynamo is coding. All right, the only difference is that instead of typing out a script or typing out a proper code by yourself, you have visual references for it. Okay, like instead of saying that I want to build a wall and then, detailing out the process of what that wall does, you have the wall element itself. So you can visualize the wall. Okay, so that's basically what Dynamo does. It shows you the output, it tells you the output rather than you having to define it or create it by yourself. Okay, so what we're going to do is we're going to first learn about Dynamo, then we'll take a break and I'll take you through Dynamo Player as well. Okay, so in order to switch on Dynamo, you can just click here. Just wait a second. So once you open up Dynamo, there are a couple of options that you'll be able to see. Okay, this is what the initial starting screen of Dynamo looks like. Okay, so on the left, you have your new files that you can create. You have the recent files and wherever you are using, like which location are you using as a backup? Okay, where your recovery files are stored. Then since Dynamo is open sourced, okay, what that means is it's not a paid software. You don't need to buy it. There's no trial version, anything like that. It's completely available for free. Okay, so the entire code of Dynamo, how it was developed, that is also completely available for free. Okay, so there are a lot of resources available which can help you understand Dynamo a lot better. Okay, so at the top, we have the Ask section, wherein it will take you to a community forum where you can ask questions, you can see what other people have asked, respond to them, those kind of things. You have the Dynamo website itself, wherein again you have FAQs, you have installation guides, those kind of things. Okay. Then you have reference. So the reference section is everything that you need to know about the software. So you have Dynamo Primer, which will take you through like a quick introduction to the software. Okay, you have video tutorials. I personally don't recommend the video tutorials because they're a little outdated. Okay, but if you want, you can go through them. They cover some basic scripting in Dynamo. Okay. Then you also have Dynamo Dictionary, which is going to take you through what the different nodes do, what do they stand for, what are the different terms that are used when you're working with the software. Okay. Then you have the code, which is the code for the program, like the code for the software itself. And at the last, you have some sample files that like sample Dynamo scripts that you can use. Okay. So Dynamo files have the extension of .dyn. All right, whatever you create in Dynamo, whatever script you create, it's going to be saved as .dyn. All right. Now, beyond this part, we also have the main menu bar at the top. Okay, there's not a lot that you need to do in the main menu bar. Okay, you have your recent options, you have some edit options. Most of those are something that we can use only once we get into the interface of Dynamo. Okay, so what I'm going to do is I'm going to click on new. Okay, so here we have the actual space where we would be working. So you have your working plane, you have your X, Y, and Z axis, and then on the left, you have your library. Okay, this library is going to contain all of the nodes of Dynamo. Okay, these nodes define what you can do. Okay, what is an action that you want to take. Okay, now beyond the nodes that are already there. So from dictionary till units, these are the nodes that are already existing as a part of Dynamo. Beyond this, you can add uh, other packages also. Okay, so how do you do that? So we can come here to packages. We have package manager. Okay. Now in this package manager, you will see various developers who have created custom nodes or custom things that you can do or utilize with Dynamo. So for example, Lunchbox is a plugin for Grasshopper. They have a Dynamo version as well. Okay, similarly, there's a lot of other versions, other packages that are available. Dyroots has their own package that is available in Dynamo as well. Okay, so there are a bunch of different packages that you can check. You can, take a look at them. Okay. So for example, I have this Archilab package installed. Right. The reason for that is that it has a lot of architectural notes that I can use. Okay, notes that I can use for architecture modeling using that. Okay, so we have this Archilab plugin, Archilab package installed. So here you will be able to see, like if you go to view details, you'll be able to see like a basic definition of it, what versions is it supported. So here you can see with Archilab specifically, they have named it in a way that I have the version of Revit first. It's not necessary that this would always be the case. As you can see over here, like Clockwork does not have a Revit version at the start. Okay. But you can always check the details and see which version of Revit is it supporting. So if let's say, for example, I would be working with 2020. So I can scroll down and pick the version that's compatible with 2020. Okay, right now I'm working with 25. So I have that version installed. Okay. Similarly, you can install a bunch of different packages. These are all just additional content that you can utilize. So how you have your Revit library and you can download extra library elements like extra furniture or things like that, or create your own custom furniture. That's what, like, that's an equivalent of nodes in Dynamo. Okay. Now, one major thing that you need to remember with Dynamo is that it will work only for the project in which you have opened it. Okay, so right now, for example, I'm in project 1. I have opened Dynamo. So it's telling me that the run is completed. Okay, if I move to project 2, okay, if I move to project 2, it will give me this error that we are not in the right document. Okay. If I go back, it will again just tell me that Dynamo is now available. So you can use Dynamo only in one project at a time. If I want to switch between projects, I will have to save, close Dynamo, go to my other project and open it again. Okay. The reason for that is that Dynamo picks up data or picks up information from the project it was opened in. So Dynamo in itself is unitless. Okay, it has no units, it has no measurements, nothing. All right, it will pick up the units from your project. Okay, there are nodes that can change units for you and do all of those things. We'll get into that later. But it will pick up units, it will pick up measurements, it will pick up dimensions, everything from the project it is opened in. All right. So you have to be in the right project when you are working with the software. Okay. Now here we have two options. Okay. This is a view where I can place my nodes. Okay. So we have two views over here. One is the script view or the graph view where we have our actual script that we create. And the other view is our 3D view. Okay, if we move to the 3D view, I can zoom in, I can zoom out, I can orbit, whatever I want to do with my geometry. That is what I can do in the 3D preview. Okay, so if I want to work on the script, I'll be in my graph view. If I want to see my output, I will be in the preview. Okay, so let me just show that difference to you. Now, let's say I add a point node. Okay, so you can see here that I get a point. Okay, I can see my node information. I'll explain this to you in a second, but I have created a point using a node. Okay, so I can see my point over here. I can't do anything to this point. I can't, orbit nothing. Okay, but I can see my node. The moment I go to my 3D view, okay, I can now navigate with my point. I can move it. I can, change its position, anything that I want to do. But this script of mine becomes unavailable. Okay, I can't move this. I can't make any changes to it. Okay, are you guys following me so far? Yeah. Okay. Now, since I moved this particular point as per my requirement, okay, I have automatically generated a couple of other nodes on this side, which is defining what is the position of that point. Okay, so if I go back to my graph view and I change this, okay, you can see that the number changes over here as well. If I, let's say, move the green point, like along the green axis, I have another node that is generated for me. Okay, so I have X, Y, and Z. Okay, so here you can see X, Y, and Z. If I take this point, I move it anywhere, these numbers automatically change. Okay, if let's say I try to bring it down to 0, which would be difficult because it doesn't snap. Okay. So my numbers keep on changing as per whatever my position is. Now, if I take any of these and I delete it, okay, let's say I delete the Z1. Okay. So that changes my point position again. Okay. It reverts it back to 0, 0, 0. Okay. It's brought it back at the origin. Okay. So that's the difference between your graph view and your 3D print. Okay. Now, let's understand what are these nodes, what do they do, how do we work with them. Okay. So we have different categories over here that are available according to what is the kind of node we want to work with. So we have some geometry nodes. We have a separate section just for Revit integration. Like if I want data from Revit, I can use the Revit nodes. Okay. If I want something like a node related to units, I have a specific thing. If I want something related to input, I have a specific, section for that. So let's focus on geometry for now. Okay, so under geometry, I'm going to go to points. Right, so here you will see we have three different kind of nodes. Okay, you can see three colors over here. You have a plus icon, which is green. You have a lightning icon, which is yellow, and you have a question icon, which is blue. So every node that you create in Dynamo can be divided into these three sections. Okay, so plus or the green ones are nodes that add something. Okay, they add data, they add information, they add geometry. Okay, they create something for you. those are the plus nodes. So for example, when we had used the point node is a plus node. So it added a point for, okay. You have the lightning nodes, which make or do an action for you. So if I have a point and I want to do something to that point, okay, for that I will have that action node. Maybe I want, maybe, I have a line and I want that line to generate a point at a specific distance. So for that, I will have my lightning nodes. Okay, they will do an action for me. They will perform a function for me. Okay, then you have query nodes. Okay, the question mark ones, which will generate data for you. Okay, they will take the existing action that you have. So let's say, for example, I have this point by coordinates. Okay, I have a point at 0, comma 0, comma 0. So I can use these query nodes. Okay, and it will tell me what is the action or what is the data that I am getting. So I wanted the x coordinate. So I used the x query. So it's telling me that my x coordinate is 0. Okay, if I change it here, okay, so now it tells me that my x coordinate is 22.7. All right, so it's just a way for you to generate data or get information from something that is already existing. So right now, obviously, I did it for a Dynamo element. You can do it for Revit elements as well. Okay, if I maybe just want to get the height of a level, or if I have a family and I want a specific parameter information. So I can do that using these queries. Okay. So those are the three different kind of nodes that we have. All right. We have the create nodes, the action nodes, and the question or the query nodes. All right. Now for every node, the node has a particular anatomy of its own. Okay. So what it does or how a node functions is at the top, you will have information or the action or the output that the node gives you. Okay, so here it tells me that it is going to give me a point by coordinates. All right, so here at the top, if I hover, it will tell me that it generates a point for me on the basis of the 3 Cartesian coordinates. Okay, we also have a point by coordinates in just the x and y axis. Okay, so at the top, you have what the node does and how does it do it. Okay, on the left, you have inputs. So I have my X, Y, and Z inputs because this particular node requires 3 inputs. It needs an X coordinate, a Y coordinate, and a Z coordinate. Okay. If you don't have anything attached on the left, it will revert to a default value. So for this particular node, the default value for X, Y, and Z is 0. Okay. On the right, you have the output. What is this particular node going to give you if you have the proper inputs? So it tells me that it's going to give me a point. Okay. At the bottom, you're going to have data that is related to that particular node. Okay. So here it tells me that my XY, I have a point which is at X, Y, and Z at 0, 0, 0. Okay. So that's the basic anatomy of a node. And at any point for your purposes, okay, if let's say I am adding a lot of nodes or I want to rename this to something custom, like it's performing a separate specific action for me, like this is my origin or this is my starting point that I'm generating. So I can always just double click on the name and rename it. Okay, so in that case, you get this blue icon on the side. which says that you have renamed it from something else. All right. Are you guys again following me so far? What are the different kinds of nodes? What does an individual node look like? Yeah. Okay, perfect. So one way to add your nodes is through your library. Okay, I can just go to the specific section, I can click on it and it'll get added to my screen. Okay. Another way to do it is you can search for a specific node here at the top. Okay, so now let's say I want to assign a value to X, Y, and Z. Okay, so for that I need an integer. So I can just search for integer. Okay, so it tells me that I have an input node. Okay, you see the icon, the lightning icon, which means it's going to give me an action. Okay, so this particular node is an integer slider. It's going to give me integer numbers. Okay, so I can just click on it again. It'll get added to my screen. Okay, the third way to add your nodes is you can right click on your screen. Alright, so usually the way that I work or people who've been working with Dynamo for a while work is in order to make the maximum use of their space, they usually have the library collapsed. Okay, because I can just right click, search for the node that I want and have it here on my screen. So let's say I want a number. Okay, so I have a number slider as well that I can include. Okay, so now what is the difference between an integer slider and a number slider? Okay, so an integer slider would always give you integers, which is it won't give you decimal points. It could be positive, it could be negative, but it won't give you decimal points. Number sliders will give you decimal points. Okay, so I can change my integer slider to whatever I want. Whatever is my minimum value, let's say my minimum value is -10 and my maximum value is +10. Okay, so now if I move my slider, you can see that the value that I get, it ranges from -10 to 10. If I don't want a step of 1, okay, step is the interval between two consecutive numbers. So I can change that step as well. Maybe I want it at 5. So now if I move my slider, it would only snap to -10, -5, 0, 5, and 10. Okay. The same logic follows for the number slider also. So here also I can say 0 to 10 and my step should be 0.1. So here you can see it ranges or it increases or changes in the increments of zero point 0.1. Okay, you can change your decimal to whatever capacity you want. Okay, accordingly, your slider would change and adapt. Okay, so this is just a way for you to define the precision and this is to control the range. Okay, so what I'm going to do is, let me just delete this number slider for now. Okay. So I have this integer slider which ranges from -10 to 10 at an increment of 1. Okay. Now here you will see that I have this output. Okay. There's no input required for this integer slider. All right. Like if I collapse this, you will see there's no input area. All right. There's only an output area. Okay. So I can take this output, connect it with my X coordinate. So here you will see that on my x-axis, it has moved along the number that I have specified, which is -10. Okay, let me just zoom in slightly. Okay, so it is at -10 right now. If I change the number slider, like if I change the slider from here, you can see the point move on the screen. Okay. Now, the reason why this is happening or why it's working automatically is because we have set our script to automatic. Okay, so at the bottom of your interface, you're going to see automatic written over here, and next to it, you will see run completed. What this means is whatever changes you do in your script or whatever you're working on your interface right now, okay, it will get executed immediately. Okay, your output will keep on updating as in how you keep changing your input. Okay, usually we only keep automatic for smaller scripts. Okay, where we're not doing a ton of work, we're not working with a lot of geometry. Only in those cases we work with automatic. Because the issue with Dynamo is also that if it crashes, if Dynamo crashes, it will crash Revit with it. Okay, Dynamo will not never crash by itself. It will make your Revit also not responding. So if you've not saved your work or anything like that, Revit would also crash. Okay. So generally, like a standard practice that we follow is before running Dynamo, always save your projects. Once you are running Dynamo, always instead of automatic, you can keep your runtime to manual. Okay, so when you do that, it will never run your script by itself. Okay, so even if I change my slider, for example, over here, okay, it's not changing the position of my point because I have not run the script yet. The moment I click on run, now my point would change. Okay, if I bring it back again, no changes over here till I click on run. Okay, so it's just a way for you to make sure that your script does not crash. It does not mess up your project file either. Okay. There's a third method as well, which is periodic, which is what you use if you want to conduct or run the script at specific time intervals. So this could be for saving your project, this could be for analysis, it could be for form finding, whatever. If you want to maybe, run your script every 30 minutes or every 15 minutes, you can set it to periodic as well. This option becomes available only once you have a time-based node in your script. Okay. So for now, let me just keep it to automatic so that, there's no changes happening. Okay, so we have the integer slider, it's connected to X. Now, every um, output can be linked to multiple inputs. Okay, it's not necessary that the integer slider that I have can only be connected to X. I can take the same and connect it to Y. I can take the same connected to Z also. Okay, but every input can only have one link. Okay, I can't have uh, let's say another integer slider and then connect it to X and have both of them linked. All right, that is not how it works. X can only have one value. Either it is this node or it is this node. Okay, I can't control or I can't change it to multiple nodes. But this particular node, again, I can just connect it to different uh, nodes. Okay, so let's say I have this integer slider, okay, at 0. Okay, I'm gonna generate another point. So let me just control C, control V. Okay, and this one is going to be at 10. All right, so this is what it looks like right now. I have one point over here, another point over there. Okay, now you will see that the output for both of them is point. Okay, so we have point 1, point 2. Now, let's say I'm, very new to Dynamo. I don't know what to do further. What can I do with 2 point inputs? So in case you have any confusion like that, where you're not sure what is the next step, if you double click on any of your outputs or any of your inputs, it's going to give you different options. Okay. So it's giving me options of what are some of the inputs, sorry, what are some of the outputs where I can use this particular point. Okay, so one option is I can make a list. Other option is I can create a line if I have 2 inputs. Okay, so you'll see a confidence rating on the left as well, which is how confident is Dynamo with this particular result. Okay, so let's say I select this one, which is by start point, end point. Okay. So I have the first output, which is the start point. Okay, then I can also connect the second one. So when it is not connected, I don't have a line. All right, this reads in red that I don't have an option or it's not connected over here. Okay, once I connect this point, I now have a line. Okay, so here you can see it says that the line start point is XYZ0 and the end point is XYZ10. Okay, you also get the direction in vector format. And then at the last, you get the length. Okay, so now once I have this line, what else can I do with this line? So I can again just double click. It'll give me options. Okay, so let's say I go with length. All right, so what is the length of this particular line? I can see that here at the bottom. We also have a view node. Sorry, watch node. Okay, wherein if I don't want to see the result like this, so this is getting in the middle. Okay, if I don't want to see it like this, I can just connect it to the watch node and it would give me the output. Let's say here, my output is 17. If I was connecting this line directly, so it gives me the output of the line. Whatever I can see here at the bottom is what I will see here in the watch node as well. Okay. So I have, these couple of options that exist. But beyond this, now let's say I want, let's say I want to create multiple points. Okay, so I can't just sit here and keep on, generating different points by making replicas of these. How do I create multiple points at the same time? Okay, so for that, we have another node which is known as the range node, okay, which is this one. All right, so this range node creates multiple numbers for you. Okay, so here you can see I have my start, my end, and my step. Okay, the same thing that we had over here, the minimum, maximum, and step. Okay, so what I can do is, let me just get rid of some of these. So I can say that this is my start point. I'll make a copy of this. Okay, my endpoint can be 10. This can be -10. All right, and my step, I'll keep it as 1. Okay, the default value it says 1, so let me just keep it at that. All right, so now once I have this list, I can again just say point by coordinates. Okay, and I can connect this list. So you will see here, I have 21 outputs that I'm generating. I can take this list, connect it to X. So you will now see that I have multiple points all on the x-axis at different intervals. Okay, I have 10 points all on the x-axis at different intervals. Okay, and again, I can connect it to my line. Okay, so here now you can see all these individual points are connected to that one endpoint by lines. Okay, similarly, if let's say, I change this to X, Y, and Z. Okay, Z will not work because it's just giving me one line. Okay, so I have something like this. I can do the same thing for this one also. I can take my list and connect it to Z. Okay, so now I get something like this, where this point also has multiple outputs. This point also has multiple outputs, and all of them are now connected to each other. Okay, so again, if I just see this, you will see 21 lines that are generated, and you can see how they are connected. Okay, which point is connected to which other point, what is the position, what is the length, you can see all of that. All right, are you guys following me so far? Yeah. Okay. Now, other than this, what we also have now, let's say, again, I don't want to do all this complicated stuff. Like just to generate one mesh, I had to have so many nodes. Okay, I don't want to do that. So, first thing, when you're working with larger scripts, okay, there's limited screen that you have. So it can be a little difficult for you to make sure that everything is readable, everything is understandable. So we can always group our nodes. Okay, so I can take this, I can right click and I can just say create a group. Okay, so it creates this color coded group for me wherein I can collapse it and it would now show me only what is the input that is required and what is the output at the end of the script. Okay, so my input right now, where I've not already added something, is my step value and my Z value. And my line is the output that I get. Okay, so I can change this. I can just say that, this is to generate a mesh. Okay, and I can uncollapse it as per my convenience. Okay, so this makes sure that you can utilize whatever limited amount of space that you have. And the closer you place your nodes, okay, the uh, shorter this group is going to be. Okay, so I can also just come here on these three dots. I can ungroup them. I can change the style of it, like if it is a specific action or, like the plus, lightning or query. Okay, I can change all of that over here. You can change the color to something else as well as the font size. Okay, so if I want it to be smaller, I can change that. Okay, now what you can also do for individual nodes as well as groups is you can preview and unpreview geometry. Okay, so what preview geometry does, what does this do is if I check this, it will just hide whatever this node was.
I really want to see what you will do.
Nandini, do you have a doubt?
What you will do?
Okay, I'm just gonna. Okay. So yeah, what you can do is if you uncheck preview geometry, you won't be able to see what that particular node does. Okay, it just hides the output for you. So even if I take this and I uncheck geometry, okay, I uncheck preview geometry just for lines. So now it's only going to show me the points. It's not joining them by lines anymore. Okay. It would also show a gray bar at the bottom, which means that this node is right now hidden. Okay, at any point, I can just say preview geometry again, and now my nodes are joined back. Okay, so that's what groups do. Now, let's say, let me just hide this. Okay, now rather than doing this entire thing, we have a specific node in Dynamo, which is known as a code block. Okay, so in order to generate a code block, you can either just search for it, or if you double click on your screen, a code block is added. Okay, so this code block also works in uh, design script language. Okay, so I can just say, let me just add a label to this. Mhm. You can't find the label thing. But what you can do is whatever nodes that you used. Okay, you can write them in the design script language over here, and it would prove or it would give you the same output. All right, so let's say I want a point. Okay, let me just zoom in so that you can read it. Okay, so I want a point by coordinates. Okay, and here I can give it a value. Okay, so let me just say 0, comma 0, comma 0. Okay, this is my first line of code. So now I have a point which is at 0, comma 0, comma 0. Okay, again, I can add another point by coordinates. Okay, this can be at 10, comma 10, comma 10. Okay, semicolon, enter. All right, so now 2 points. One is at 0, one is at 10. Now, how do I connect a line through these? Okay, because if I want to create a line by start point and end point, I have to define what my start point and what my end point is. So how do I do that? So for that, first, I will have to give an identity to my first point. So I will say A equals point by coordinates. Okay, this would be B equals point by coordinate. And now my line by start point, end point would be A, comma, B. Okay, semicolon, enter. So now it has joined both these with the same line. Okay. Apart from this, what we can also do is if I don't want to add values over here, okay, I want to work with the range part of things. So instead of 0, I can make this a variable that this is X. Okay. So now I get an input over here that I need an X coordinate because I've added a variable here. Whatever, however I change this variable, let's say I name it G. So now my input also becomes G. It's not necessary that this should always be X. Okay, so I can now just add a range node. Okay, so here you can see you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, if let's say I take point B and I change the variable here as well to G. Okay, so here you can see how those other points are also created. Okay, if let's say instead of G, I name it H or something. Okay, some other variable. So now I have another input that is added for me. Okay, so here also I can add a range node. Let me just search for number. And the number could be maybe 20. So accordingly, this would update for me. So rather than having to go through this entire process, okay, I can just write it in a code block. Okay, so here also I have that option. I can add the range part here itself. Um, yeah, with the help of list, I think. Well, yes, there's some other way, but we can add the range node in the code block also. But it's just a more condensed way of you being able to work with things. Because whatever I have in this part, okay, all of that can be condensed into this one code block that I have. All right, so it's just a way for you to keep your scripts a lot cleaner. Whenever you have easier nodes, easier things to do, you can use the code block for it. Okay. The benefit of working with code block is that it will give you ideas. Okay, so like let's say if I want to generate a mesh, so I can just type in mesh full stop. Then what is my method of creating it? So if let's say I want to create it using points, so I can mention that. Okay, and then it would also tell me what is the input that is required. So I need point and I need indices. Okay, so it'll just give me a complete breakdown of what that particular node is supposed to do or what that particular thing is supposed to do. All right, following me so far? What is the script? How does code block work? Okay, these lines in the middle, these are known as the connectors. Okay, they connect your input to your output and vice versa. Okay, clear so far, everybody? Any questions so far? Okay. Now, whatever we created so far was in Dynamo. Okay, it does not affect our Revit geometry whatsoever. Okay, how do I bring Revit into Dynamo and how do I take Dynamo outside of like into Revit? So for that, we need to work with these Revit um, elements. Okay, these Revit nodes. Okay, so you will have uh, Revit elements, you have filters, you have geometry, a lot of different things. Okay, you will have like a bunch of different elements that you can bring in, bunch of different nodes that you can bring in. So let's say I have walls. Okay, so let me just close this for a second. Let's say I have walls here in Revit. Okay, basic wall. Okay. Now, if I want to bring this into Dynamo, I have a bunch of different options. Either I can bring all elements that are at a specific level. I can bring in levels themselves. I can like select a level from the document. I can bring in faces. So you have select face or select faces. Okay, then you also have family instances. You have select model element, a bunch of different options. Okay, so for now, let me select model elements. Okay. So the moment I click on that, it's going to tell me to select something in the model. All right, so I'm going to click here on select. Now you will see that Revit gets activated. Okay, sorry, I have to use the other mode, which is select multiple. Okay, so I'll click on select. It's not open. Select multiple is not working. Let me just go with all elements. Okay. Now here I can add a level. Okay. So I have L1, L2. I can just select L1, add this. Okay. And let me just zoom to fit. Mhm. So you just give me 1 second to figure this out. There's a node that I'm missing. Let's do one thing while I figure this out. Let's take a break. Okay, post the break, I'll show you how to integrate the Revit things into Dynamo and how can we use it further. And then we'll also go into the Dynamo viewer. Alright, it's 9:08 right now. Let's take a 15 minutes break. Okay, let's be back by 9:25. And then on the other side, I'll take you through this particular part and Dynamo Player. Okay, is that okay? Yes, no. Alright, so I'll see you guys back at 9:25. Is everybody back? Let's get started again. So I will share my screen. Okay. So, so here we have some walls. Okay, now if I want to see these walls in Dynamo, we have a couple of options. Okay, so I'll first search for the select model elements. So either we can select it by a category or we can just select it directly. Select model elements, click on select. Okay, I've selected all of them. I'll click on finish. Okay, now in order to get that geometry in Revit, sorry, in Dynamo, we have element geometry. Okay, so here I'll connect the element node and we'll get the geometry. So I'll go to the 3D, we'll zoom to fit. Okay, so we can see the walls that we have created. Okay, similarly, I can add more walls, more elements, and I can bring those here into Dynamo. Okay, now whatever we have in Dynamo, okay, this geometry that we have, right, I can turn that into Dynamo elements also. Okay, the only difference is that I will have to use my geometry nodes in order to get individual lines, in order to get individual points and those kind of things. Okay, so I can generate lines. So you can see we have like a bunch of surfaces that are created. Okay, and I can take any of these surfaces. If you click on any of them, you can see the location of that surface. Okay, I can take any of that surfaces or I can explode it further also. If I just take this Control C, Control V. Okay, so now all of that is broken down further. Okay, so this is one thing that you can do. Then you can turn this further into dynamo geometry, and then you can use dynamo geometry to get elements in Revit. So how does that process work? So we have a couple of options here. Okay, so we have, like, if let's say I want to create a wall. Okay, so for walls, I have the option to create it using curves. Okay, so I can select this wall by curve and height. All right, now here I need to define what is my curve, what is my height, what is my level, and what is my wall type. Okay, so first, in order to generate the curve, we can use our initial method. So I'll search for point by coordinates. Okay, we can say instead of a straight line, let's say we want a curve which has the best fit one. Yeah, best fit 2 points. Okay. And here on the left, I'll add a range. Random. So here you can see in Revit also, we have some random points that are now generated for us. Okay, I can turn this instead of something like this. Let me just. So these are some points that we are getting. Okay, now I can take this point by coordinates. I can use this to generate an arc. Okay, so here you can see we have an arc, some sort of line that is created. Okay, so we have the path for our wall. Okay, now using this, first we can connect the arc to the curve. Okay, this can be a straight line, this can be a proper curve, anything. Okay, then you need to define the height. So let's say I want the height to be exactly 4,000. Okay. So I'll add the height. Then what is the level? Okay, so I'll use the level node. This can be the wall is located at L1. And then what is the wall type? Okay, so let's say I want a generic 200 wall. So now whatever parameters I set over here, okay, I have that same wall now in Revit. Okay, so you can turn this into like this geometry, this geometry that you're able to generate in Dynamo. You can change this into multiple things. Okay, so we also have uh, beam options. So your structural framing beam by curve. Okay, so what this particular node does is you can select the curve. Okay, so let's say this is the curve that I want. What is the framing type? So structural framing types. Okay, so we have these different beams over here. Okay, and then what is the level at which you want to create? So maybe I want a beam at L2. Okay, so in this case, then then we have this wall. made my Dynamo file very chaotic. Just give me a second. So ideally, then after this, once you have done all of this, your beam should be created. Generating for us. It's crashing. So usually the way this works is so anyway, usually the way this works is once you add the beam node, your beam is generated for you along the curve that you have selected. And then as and how you change the position of the position of the beam also moves. And it's just a way for you to ensure that whatever you are creating, okay, whether if let's say I have multiple trusses that I want to create or multiple uh, geometry that I want to create. Okay, I can do that very easily with the help of Dynamo. All right, that's pretty much what I was trying to explain. For some reason, it's not working in my favor today. But yeah, that's pretty much what you can do. Okay. Now, beyond this, like beyond what you can do with Dynamo over here, all right, you also have Dynamo Player. All right, now with every version of Revit, you also have certain scripts that come pre-installed. Okay, these are not the sample scripts. These are specifically Dynamo Player scripts. Okay, so you have this Autodesk sample scripts that come in. So you have a bunch of, content that is already available for you. Okay, this changes from version to version. So for 2025, these are the scripts that are currently available. Okay, so how it works is, let's say, I have some walls again. I have some walls again. So we have this option, like this particular script that says select all taggable elements not tagged in the current view. All taggable elements not available in the current view. So I'll just come here to Dynamo Player. I'll just select all taggable elements. We'll click on play. Sometime. So it usually is not this slow. I'm not sure why it's not working today. But yeah, what it would do is it would select these four walls for me because they are the ones that are not tagged. And then similarly, you have like a bunch of different scripts that you can run. We can also check these scripts. Okay, so here, for example, it has selected 8 things for me. It selected some annotations, reference planes, walls, and the plan itself. Because it's just things that are not tagged. All right, if I were to tag something, like if I just add a mark over here for my walls, okay, and I run the script again. Okay, so now you will see that these two are not selected anymore because they are tagged. All right, it's only selecting these two walls for me. Okay, similarly, we have a bunch of different scripts that we can work with. So for example, we have this update sheet names to uppercase. So whatever sheets I have over here, okay, I can just say play. Okay, give it a minute. Which you'll see all your sheet names are now in the uppercase. Okay, what we can also do is I can click here on edit. Okay, we'll click here on edit in Dynamo. So ideally this should open up Dynamo for me. So now here you can see how was the script created. Okay, so first it's selecting sheets. Then what is the parameter we are considering? Okay, then in order to change the sheet name, we have to get the value of the particular parameter. Okay, so here we need to add the element, we need to add the name of the parameter. So this gives us all of the names. Okay, and then here we have this node which is string to uppercase. Alright, similarly, you also have string to lowercase, you have string to title case as well. Okay, then you can change the string as the value, element and parameter would remain the same. And then you have all of the sheet names that are converted. Okay, now I can change this to anything else that I want. So here, for example, we want the parameter name. Okay, so let me just take this and open up a sheet. Okay, so for this sheet, what are the different parameters that we have? Okay, so we have approved by, we have designed by, checked by, what is the uh, sheet number, all of those things. Okay, so I can take approved by as well. So instead of sheet name, over here, I'll just type in approved by. Okay, so my parameter name has changed. Okay, I'll click on run again. Now you will see approved by is now in all caps. Okay, similarly, we also have string. Yeah, string to uppercase, string to lowercase, we have string to title case. Okay, so instead of string to upper, I can take string to title case. Let run it again. String to lowercase. Okay, so now everything is in small. If I go back, change this approved by again to sheet name, run. So all my sheet names are now in lowercase. All right, so similarly, you have like a bunch of other ones as well. So we have add levels. If I go to any elevation view, so if I am in any elevation view, let me just enable the annotations. Okay, so we have L2. I can use this add levels. Okay, click on play. Yeah. Now, since for this script, I need some inputs. Okay, so I can first select the distance. I can define the number of levels and what is the level above which I need to add the new levels. Okay, so my distance could be in whatever units that I want. All right, it's not necessary that it's always in project units. Why is that? Because here we have this option of get document units. Okay, so it's taking the project units, all right, and it is converting it to another unit. Okay, it's converting it to calculate the distance and then it is creating the levels. Okay, so whatever I mention over here, this could be, let's say 15 feet. My document is in millimeters. Okay, I can define the number of levels. Let's say I want 12 levels. Okay, we'll click here on select. I'll select the level. Okay, and then we can click on run. Okay, so here you can now see in the middle that we have all of these different levels that are created for us. Okay, we selected 12. So now we have 12 levels that are created for us. And we did not have to do this using array or create similar or anything like that. We just have these bunch of levels that are now generated. Okay, so for any script that's available in the player, okay, you can click on edit and you'll be able to see the output or see how the script was created in Dynamo. Okay, so you can check how the script was created. You can check how they were drafted. What is the purpose of these individual nodes? Because whatever scripts you see over here, they are all for Revit, right? They don't have any Dynamo requirement in them. They're all for Revit. Okay, so you can go through these. You can go through the Dynamo player scripts. Now, the reason why I'm asking you to do this is because fundamentally there are thousands of different nodes that are available in Dynamo. Okay, and it's practically not possible for you to go through all of them and understand what all of them do, right? And not all of them would serve the purpose that you want them to. Okay, seeing existing scripts is the easiest way for you to be able to understand what every node does because you can visualize the output at the end. All right. So your task also for today is going to be the same thing. All right. Apart from the reading material that we share with you, you have to go through the Dynamo player scripts. All right. And you have to recreate one of those scripts. Okay. Now, how do you recreate them? That is on you. All right. You can try to make them shorter. You can try something completely different. Okay. You can take an existing script and try to make it do something else. Okay, like how for the sheet ones we used approved by instead of the sheet name parameter. Okay, so you can experiment with them. You can try out and replicate one of the Dynamo player scripts. Okay, that's your first task. The second task would be to go through the reading material that we're sharing with you because you would need that in order to understand what we're doing in the next session. Because in the next session, we get full-fledged into automation. We understand how we can use Dynamo in order to automate our repetitive tasks. All right, so are you guys clear? Do you have any confusion?
I have a question.
Yeah.
Earlier, you were trying to make that curved wall. What is the use case you can say for it? Suppose I'm doing some facade.
Mm.
Does it help to work that way, or I couldn't get the connection between the use case and what we were doing?
Yeah, so let me just show you an example. For some reason, like my Dynamo is not working properly, but I'll just show you one. So, for example, now Dynamo can be used for generating your adaptive families also. Okay. A way that Dynamo is used over here is they had a model element. Okay, like they had this sort of an model structure, mass structure. And what they did was they took the geometry from this, like these lines. They created a Dynamo script that helped them to place trusses evenly across the facade. So now, as in how the facade updates, since we have already selected those instances, the parameters would always update and your trusses would get spaced out automatically. Okay, so that's one example of it. Just one second, let me show you the final output. Yeah, here. So depending on the number of trusses that they want, you can space them out accordingly. So you can use this for your jali walls. Let's say you have a curtain wall which has multiple grid sizes. So you want to fit a specific family in it, you can use a Dynamo script for that. You have to make sure that all of them are evenly spaced, or you have to make sure that all of them are at specific intervals. So you can use a Dynamo script for that. You can use it whenever you have an updating component, something that needs to change with how your model element changes.
So we had created this Albahar towers
Mhm.
2 weeks back.
Yeah.
Can something like that uh, be helpful using Dynamo?
Yeah, so I'll show you a Albahar script that I had made. So the way, like the script that I made for Albahar was basically, let me just open that. Let's show you. So let me just break the script down for you. So in order to create the Albahar tower, you generated an adaptive family, right? Now, like that adaptive panel that changes its angle. Okay. Now, when I want to place that panel on my facade, I have to place it manually and then use the repeat function. And then if I hide my mask, the panels also disappear. Okay, here I don't have my mask enabled. Okay, whatever geometry I have, this is actual geometry that is currently visible. This is not mask geometry. The reason why that happens is this, I created a script basically wherein I can get points for um, so I can get the points for my placement. All right, so every one of these triangles you can see we have point 1, point 2, and point 3. Okay, so those points we can import in Dynamo. We can generate those points in Dynamo. Okay, and then on that, so I'll be able to generate a curve, and on that we can place our adaptive panel. So we have the main panel that we created. I have the curve for all of these individual points, and I can place those points, place that panel on those points. Okay, so if I just show you the mass, okay, this is what the mass looks like. Now, in that mass, we have these points. You know, these points will read in Dynamo, and then Dynamo will place my adaptive component on that particular element. Okay, so if I do not get time to do it, but if I expand the script further, then we can also control the angle of opening. So here, for example, you can see 1, 2, and 3, which are the 3 points that it is considering. Okay, so right now, if I have to change the angle, I'll have to go into my properties and change it manually. Okay, using, uh, I think, Ladybug, we can check the location of the sun and we can implement that over here. That if my sun angle is at maybe 60 degrees to this particular panel, then it should open at an opening factor of 0.5 or 0.6 or whatever. So I can control that and make this into an actually responsive facade as opposed to having to change all of my pointers manually, all of my panels manually. So right now this one is just for placement. Let me just show the geometry to you. So, I cannot be the right document. This was the panel that I was working with. So basically, here you can see your panel, okay, like the mesh that you created here. You can see that here in Dynamo also, and then Dynamo uses these points, these lines in order to place the adaptive panels. So I placed it like on top of the existing mass, which is why it took a little bit of time. But yeah, we get the geometry here in Dynamo, and then Dynamo uses this geometry to place your model elements.
So it will read those points as 1, 2, 3, how it was made in the adaptive family when we were creating it.
Yeah, so the way that you guys created the adaptive family is a slightly more complicated method. But what we like what I did in order to make it easier for me for Dynamo is that instead of just working with one family, which is the adaptive family. I also had a family for just the points, which is the placement plane. So if I just show that one to you, let's just modify it real quickly. So it's just this mesh, okay, and none of this is visible in the view. So if I just select this panel, all right, so its visibility is controlled so that I don't see the panel. Okay, and this is what Dynamo is considering in order to generate this geometry, these curves, these points for me. So technically, this is also an adaptive panel because I need the 1, 2, 3, 4 points for it. Right, and then whatever mesh is generated,
The base that you created for it to pick the points.
yeah,
And on these points, your adaptive family will pick these points to be.
yeah. So I place this as 1, this is 2, this is 3. So now my adaptive family would always consider this is 1, this is 2, and this is 3, as opposed to something else or something random. So that would give me precise placement.
But then when you created this base, how does this how does this gets placed on this curved wall? Like how do these points read on your curved wall?
So, second. So instead of placing my adaptive panel as a part of my mass, so I think the way that you guys have created, you pick the adaptive family directly from here. Okay.
Also, you place the base point thing on in your Revit on the mass.
Yeah.
Okay, okay. I was wondering if you've done it through this whole script thing.
Hmm.
So that's how I got a little confused. How do you place that base? So that you have created how we did the adaptive family thing.
Yeah.
Okay, got it, got it.
So the purpose is that using this base, I can generate the points. Right? Because otherwise what happens is if let's say I don't do this or if I follow, the generic method, then if I go to my mass and I hide my mass, then my panels would also disappear. So I do not want my panels to disappear. So for that reason, instead of treating these as generic mass elements, we are now treating them as model elements. So here it reads as a generic model instead of mass. So even if I hide or show my mass, this would always be visible.
Yeah, okay. Got it, got it. Yeah,
Yep.
makes sense. Yeah. Thanks.
No problem. If you want, I can share like a screen recording of how this was created.
Yeah, I'd like to see that. Yeah, thank you.
No problem. So guys, rest of you, are you guys clear with the task, clear with whatever we covered today? It's not a big task that you have to do. All right, it's just something to make sure that you understand what the different nodes in Dynamo do. Okay, so do you guys think this is doable? Yeah. Any questions, any doubts, any confusions? Sorry, I'll just close my Revit before my laptop dies. Yeah. Any queries, any doubts, any confusions?
You were talking something about some material, no? Reading material or something.
Yeah, I'll be sharing that on the group itself.
Okay, yeah, that's it.
So, should we move towards wrapping up for today then? I think the rest of you are already asleep. Okay, so with that in mind, thank you everybody for joining. I hope you learned something new today, and we'll see you guys for the next session. Okay. with that in mind, we wrap up in 5, 4, 3, 2, 1. Bye, guys. Good night. Thank you so much for joining.